Hello and welcome. Today we're going to be continuing working on this wallpaper thing. I guess tool is probably the best word. That we started the other day. Right now it basically does like a Voronoi diagram on a picture. So like say we start with this picture of like poppies. We can get this like sort of mural effect-ish, I guess. And then what I want to do today is kind of two things. I want to make it so that this is actually useful, because right now this just kind of shows up in a window. I would like this to be able to be exported into like actually saved into a full resolution image. And then I also want to try using something called the Delaunay triangulation. Actually, let's pull that back up. Delaunay. Also, I just realized I misspelled the title, so let me fix that. There we go. The Delaunay triangulation, which is basically a method of constructing triangles from a set of points. So if we like look at my general wallpaper, which is kind of what I'm basing this off of, you see it's just a bunch of triangles. And so that's kind of the ultimate goal from this, is that we can pass in an image and tweak some settings, and then we can export into this triangle, like geometric design, I think. But before we do the triangulation aspect, on which I found a pretty decent little, I don't really know what to call this, like guide, description, from some university of Minnesota, that it covers in pretty good detail, like a divide and conquer algorithm for the Delaunay triangulation. And we'll implement this, I think, today, hopefully, if we have time. But before we get there, I want to get some more of the control aspect within our program itself. So if we look at it right now, we can say make and main on this poppies. It'll take a minute, and then it will spit out an image. We can change the color space by pressing S, I think. Right now, yeah, okay. Right now when you press it, it waits an uncomfortable amount of time because it like just automatically starts regenerating. We should probably have some amount of feedback there saying, hey, I'm loading. Arguably we should also like parallelize this or use a GPU or something, but I don't want to deal with that because that's too much work. GPU programming is not fun. Or really, I just haven't done enough with it to make it something I'm ready to do here. Hold on just one second. So no GPU yet, but maybe at some point. But I do want to give this a little bit more of a UI. One thing I thought about is there's a thing called Ray GUI, which is made by the same dude who makes RayLib, which is like what we're using for graphics. I've never used it before, but I'm pretty sure it's fairly straightforward. Yeah, it's like this immediate mode UI. I think this is immediate mode. Yeah, immediate mode UI, great. That gives us kind of UI components. I think maybe we incorporate this. Yeah, it just takes a position and some sort of text. So yeah, sure. I think let's bring this in. We can add like buttons and stuff. Yeah, why not? Yeah, so we'll add buttons so that you can configure stuff. And that'll be it. I'm pretty sure this is a header only library. Maybe. Yeah, Ray GUI implementation. So we just need to find this header file, which is source. Maybe it's distributed. Maybe it's not. Wait, where's the header? Oh, it is literally just in source. Why is it in source? Copy link. Did that say ask AI? Ew. Remove AI chatbot. Thank you. Okay, so let's grab Ray GUI. Yeah. And then within main, we're going to say include Ray GUI.h. So that's not aligned. Ray GUI.h, and then define Ray GUI implementation. This is quotes. Great. Yeah. And then down here, let's just add a button. Like, let's add a button that does, I guess, like, randomize. And let's also drop down, let's remove this fill random. Yeah, let's replace fill random here with just randomize with, like, 10 random points. And then we can create our button. So we can say if key pressed. Let's actually switch these all to be like separate if statements. Just so that they're always run. Like that. And then we can say if then within this if statement we can add the button. I forget what the syntax for the button was already. GUI button. Great, let's just copy this. And then this is gonna be, oh. That was weird. I just locked my computer. Sorry about that. Yeah, okay, sorry, that threw me off. Hello, Oleo TV, welcome to the chat. Yeah, here we're gonna say like randomize, and then this is gonna be an or. What is it? This is close. Yeah, okay. I don't know where that comma came from. Maybe I accidentally typed it. Who knows? Okay, so now we've got this. This hash 191 hash is for this little info icon. I don't know if he shows like a table of what the icons are. Ah, he does. Great. Let's see. So supports law. Each pixel is codified using 1 bit. The total size of the arrays. Oh yeah, okay, that's great. And then it's so like 191. If this is, it'd be really cool if it just gave me like a list of them. How many is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so it is 16. So 16, 32, 48, 64. Whatever comes after that. So 80, 96. Wait, we're looking for 191. So I guess 4, 8. So this is 128. Where is this I? Actually, we could just look for it that way. I for the like the info button. Is it in here? Is this the full table? It says 256, so I assume it is. Is it this button? Wait. No, it's literally an eye with a box around it. It's also possible to use the GUI. Okay. You know what? I don't care enough to look for it. Yeah. Oh, it's right there. Wait, did I miss it? Is it right there? It is right there. So if this is 256, then you subtract 16. This should be what? 240, but that's not what it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh. Okay, I suspect that it's just counting. So is there a better symbol we can use here for randomize? So like a shuffle icon somehow, somewhere. We've got some media player stuff. Ooh, not like that. Open image, new tab. Zoom in. Better. Okay. Shuffle, 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 shuffle. None of these are really terribly giving me shuffle vibes. I guess let's try like this sine wave. Doesn't really matter, but okay, so like, what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So what? Node 14 times 16. Wait, no, fuck, I did it wrong. 1, 2, 3, 4, 5. Wait. Sorry. We'll figure this out, I promise. 0, 1, 2, 3, 4, 5, 6, 7. 7 times 16 plus 14. 7 times 16 plus 14. This, 126. Is that correct? Possible. I think it's wrong, but we'll find out. Wait, no, that's definitely wrong. Okay, who fucking cares? We'll find out if that's a symbol. Great. Make and main. Undefined reference. Really? Is that not what it's called? It is Ray GUI implementation. Did I misspell that? What am I doing? Oh, we need libmath. So we go back to our makefile. We can add lm. Great. We do not have a button. Okay. Also, let me zoom in a little bit. Okay, so we don't have a button. Although I would think that that should work, so maybe this is invalid. Do we get any sort of log? Not that I see. Do we need to do any sort of initialization? GUI button rectangle show message. No, we shouldn't have to. Okay, I don't know why we don't have a button. That's questionable. What if we do this outside of the if statement? Yeah, we still don't have a button. Why do we not have a button? If we say draw, do we have music? I feel like that stopped. Okay, we have music now. Sorry. Draw rectangle at 24, 24, 120, 30, red. Just draw a rectangle here. Just make sure that we know where the button is. Oh. Oh, I'm being stupid. We draw the actual grid after we do all this input stuff. This should happen first. Or not the grid, but the image. Hey, look at that. We've got a button now. Very, very cool. Feel like a web developer. Okay. We have now got a button that will randomize and add a bunch of random points. Okay, cool. Yeah, okay, so let's say, so we also, part of our input is that we have this, is mouse press, this guy. We don't want to do this if we click on the button. It's a little bit weird because, as far as I'm aware, we don't have a way to just like ignore that event if any button is pressed, like automatically within RayGUI. Although I don't think there's really a library reference in here. Yeah, so actually, can I just go to the implementation? Does it set any sort of variable? Anything like global? State is the state of this button. Yeah. Okay, so I don't think there is like a global place. So we can just say like bool clicked is false. Clicked is true. Technically this will be set if we press R during this frame, but I think it's fine because it's very unlikely that we press R and click in the exact same frame. So then down here, if we say, where do we do the mouse? Also the mouse should probably be at the very, very end. So if we do the mouse down here, wait, where's our drawing of the background? Clear the background, draw the texture, should also be at the bottom. And this can, we don't need parentheses here or here. Okay, did we lose music again? What the fuck are you doing? Okay, now we're back. Yeah, so now if mouse button pressed and not clicked, then we can do this. And the click gets set to true here. So theoretically, now when we press this button, oh, I'm being fucking stupid. This display needs to happen at the top. I moved it up. Great. So this click should not add a point. Except it did. Fuck. Never mind. Let's see. Clicked equals true. Oh, I think it's because button pressed happens when the mouse button is released. Is that true? I think that might be true. Let's say mouse button. I don't want to use down though, because down is like gonna happen every frame. Wait, no, pressed? Yeah, pressed definitely happens on mouse down. Maybe this is just unavoidable. Button control returns true when clicked. Toggle button control? Oh, for like a on or off, like a checkbox. Interesting. Icons, enable tooltip. The key, bunch of stuff. Nothing in here is particularly useful. I want to see if there's a way to like do mouse events only when you're not hovering over a button. But honestly, I'm not really too concerned if we want to like kill the mouse events just outright. It's not particularly useful. Yeah, let's just remove mouse events. They're not super useful anyways. Mouse button pressed, and then we can remove the clicked. Okay. And then, so now we've got our randomize button. Let's remove this text. And then I actually want to say all of these button. Oh shit, that's gonna be a pain. Because I want to basically make all of the buttons be able to be turned off. So right now, if we bring back this text, if I press O, I think, it'll turn off this text right here that says color space. Yeah, so it goes away so you can see the full image. So if you wanted to like generate the background, you could just turn off the UI so you can see the whole thing. I want that functionality, which is a little bit weird because of this now. And it has to be on this side, because if it's on this side, then it's gonna... Actually, I'm curious if we'll see that. It'll disappear when you press R. Yeah, you can see it. I don't know if it shows up on the stream, but when you press R, it flickers because of the short circuiting that happens in C. And we can get around that by doing this. Yeah, because now it's doing a binary operation, which means it does still call this function. And we can do show overlay, and there. This is a little bit of cursed C, I think, but it's fine. Basically, this will always run every frame. This entire thing will run every frame, but this function right here, the GUI button, will only run if show overlay is true. So we can randomize. If we press R, nothing happens. We click the button, it'll randomize, but then we can turn off the UI and everything still works, but we can still, or everything goes away, but we can still randomly generate points. So that's cool. Let's see, what is this? This is basically fill the grid, like refill the grid. Or not the grid, but the screen. So generate a bunch of new random points. So I guess more accurately, this is add random. And then we can do another thing here, which is going to be show overlay and a GUI button that has the same bounds here. Where the Y value is now going to be plus 30 plus, I don't know, like 5 pixel gap. And then the text here is going to be randomize. I think randomize is a better term here. And then we need closing parentheses. Okay. So now we've got our add random, which just adds 50 random points. And then we've got randomize, which will kind of clear the whole grid, and bam, it will draw, or it'll redo the thing. Your FFT thing encouraged me to make my own FFT toy. Cool. You're welcome for the inspiration. I like doing the random like visualizations and that kind of thing. That's actually kind of how I started programming, is doing like the creative coding and stuff like oh, what's his name? Daniel Schiffman from like the coding train. A lot of what he did is kind of how I got into programming, I think. But yeah, so now we've got some buttons here. Very nice. Let's add more. So we've got points is to whether we want to display points. So here we're going to say if the P key is pressed, or we're gonna have a show overlay and a GUI button, this guy, times 2. And arguably we should extract these into variables, but that's too much work. Yeah, then here I want to say, if we're showing points, then it should be hide points. Otherwise, it should be show points. And I really hate formatting if statements. This is bad. This looks bad. But it's fine. I also feel like a React developer using ampersands to show and hide different things. This is questionable. But it's fine. So now we say show points, and it shows the points, hide points, and it hides the points. Beautiful. Great. What's next? Texture. This is whether we're showing the background texture. This is gonna be basically the same thing, except we're gonna use key T. Like this, and this is gonna be hide texture and show texture. Texture. So now T still works, and we can click this button. You'll notice that these are in the same spot. So we need to increment that counter. Great. So add random, randomize, which will redo the grid. Show points shows all the points, and show texture can be toggled. Except, wait. Oh, I forgot about that. When we show the texture, we regenerate it. That might be something we can turn off. Hide. Oh, actually, you'll notice this is also still synchronized with the points. So let's change that to use show texture. Also, these buttons are kind of small. Let's make them bigger. How do we make them bigger? You know, okay, fine. We'll extract these into variables. So let's say, what are these? These are probably floats, would be my guess. Really? Yeah, okay, floats. So this is gonna be like float padding is 24 is what it is right now. Float button width is 120. Button height is 30. And gap short is 5. So this is padding, button width, button height, and then down here we're gonna say padding plus button width plus button plus gap, and actually really like button spacing is button height plus gap. Height. And then let's do int I 0 button I. This is getting nasty because these variables are getting pretty long, but that might be fine. So button spacing times I plus plus. It's called button I, and this is for the index of the current button we're on, so that we can just like increment as we go down, and we can use the same thing down or up here. So this is button width, this is button height, and arguably since we're in this now, yeah, since this is always the same, let's go to function, which returns a rectangle, which is the button area. No, button rectangle, which takes in the mutable. This is not Rust. What the hell? It's an int pointer to the button I, and then this is just going to return this rectangle, where button I is incremented. And then for these variables, these can go ahead and just be like global constants. In fact, let's actually use hash defines here. Except not for this one. This one we want to just use as a local, I guess. Float button spacing is the height plus the back. And then this is going to be define, and these are going to be uppercase. Oh, not button spacing though. Great. So now we are creating the rectangle that can be used for the button location. Let's be a little bit more explicit about this. This is .x. This is .y. This is width. And this is height. Like so. And then we can use that by saying down here, you can say button, rect, and say button I. Like that. Now it's fairly small and will automatically like tile. So same thing here. And then same thing here. And I think that's all we have. And then if we run this, it is not correct. Why is that not correct? Let's see. Wait, where's the button rect function? This guy. Button I should be incremented. So why is it not? Let's do a printf and say button I is this. If we run this, we get a bunch of stuff. Oh, because it's a pointer. It's always 0. Why is it always 0? Yeah, okay. Order of operations in C. It's beautiful. Okay. Great. So now we've got buttons here, but now the text is still small. And I feel like the text auto scales, but it's been a long time since I've actually looked at this library. Does it say anything? There's not really a whole lot of detail. Let's just make the button smaller and see what happens. Button height, let's make it, I don't know, 60. No, that's not any bigger. Button width, let's set it to 240. That's still not any bigger. Okay. How do I make the text size larger? Let's go into the GUI button. Let's see if there's anything up here for the font control. Bunch of stuff, nothing I care about. Okay, down here. GUI enabled, all that stuff. GUI set font. So there's a bunch of like controls. Advanced control set. Oh no, this is just for more advanced things. Icons. Oh, there's just like a list of icon names. Okay, I see. That's fine. I don't care about any of this. And then the implementation. So, I mean, this is actually a fairly small library. Get GUI text width. icons, tooltips. Let's see, is there anything in here about text? Or maybe size? Font size. Load font X. I don't want to have to load a font. Control text size, glyph max height. It's commented out. Which text styling properties? Ooh, okay. Text size equals 16. But that's for an enum. The GUI default property. What is... I just look for text size or size. Comes with a default style loaded automatically at runtime. I mean, yeah, this is the font. That's great, but what is the... Or how can I change the font size? Is it even possible? GUI extended properties depend on control. Okay, that's great. Where's this used? It's not. GUI property. Property. GUI set style. Let's try that. What is control here? Actually, let's go see what this function is defined as. Set one style property. That's great, but what is control? Control? Oh, GUI control. I see. Okay, so this is going to be 0. So let's try GUI set property. What was it? Set control. Ah, fuck. I forget what it's called. Property. Or property. This GUI set style. GUI set style. Default was the control here. Yeah. Property is text size. Let's set it to 30. Hey, look at that. We have bigger text. Okay, great. Very nice. Okay, so now we have an add random, which will do that. We have randomize, which will clear and randomize the screen. Cool. Show points. We'll just show the points. Hide the texture. We'll just show and hide the texture. And really, if the texture is already rendered, then we shouldn't have to re-render it. Let's do that, because that's... I mean, it's not pretty... I don't know if it's worth it. When we do our Delaunay triangulation, we're not going to use the texture. At least not at first, just because it is... Like, that's a lot of overhead, and we don't really care about it while we're doing the triangulation itself. But I think it's fine. I want to change randomize. There is a function, or not a function, but a control that has, is it called value box? Is that what it is? Let's look at this image. Nope. This image. Yeah, over here we've got this like spinner. I guess. I was kind of hoping for something more a little bit like the, if we look back at the, here, somewhere. Yeah, here, there's a, those are spinners. Okay, sure, we'll just use a spinner there to to change the number of points that we generate when we press randomize. Although, wait, no, that doesn't change anything, because fill random just keeps adding until we are full. Although, you know what, honestly, yeah, let's do that. So I wanna move this fill random from being in a single from being the single loop that just keeps going in a single frame. I want to move it to continuously go over frames. So yeah, let's say bool adding points is false. So this is like state. And then what this will do when we press randomize, it'll say adding points is true, and I think I misspelled that. Adding pints is true. And then what we can do is I guess down here, if we're adding points, then I want to say what do I want to say? Randomize into P, like just, I don't know, like 50, 20. If randomize this is 0, meaning that we have added no points, then adding points is going to be false. So now if we press randomize, nothing changes. Oh. I'm so confused. Why did that not work? Let's see. So if we press this, I mean, we don't really want to call Voronoi immediately after that. Although, I don't know, it's weird. I kind of want to do this each time. But that's going to slow it down quite a bit. Yeah. See, it looks cool, but it does make it so much slower to do this. And in fairness, the algorithm that we're currently using to actually add points to the screen is so slow. It just keeps trying to add points. And then if it collides into something, that it'll just try again elsewhere. Yeah, this is really, really slow. And it's made significantly slower because we're redrawing the Voronoi each time. And like, we could be smarter and only redraw it around the certain points, but I don't think that's worth it. We're not allocating when we redraw the Voronoi, right? Like, we don't have a malloc anywhere or any sort of allocation. We've got allocation in our dynamic array, which we just use for points, so I'm not concerned about that. If we were to increase it to 1,000, it does make each step slower, but it will finish a lot faster. Or I guess it'll finish in fewer steps. And like, really, we should probably disable the UI while we're drawing points. Like, there's a way to, it wasn't in here, it was in here, although not like actually here, but like up here at the top, there is a GUI lock, which it says lock GUI controls. Yeah, let's do that. So let's do like here, if we're why can I not type? What the hell? If we're drawing or adding points, what the fuck? Adding points. I don't know why it keeps trying to do like C++ things while I'm actively writing C. Like it knows I'm using C, but it keeps like trying to autocomplete with C++. I don't know what that's about. So if we're adding points, then I want to say GUI lock. I do wonder, like, do I need to call this every frame or what? So like, do I have to do, if we're adding point, I guess, else GUI unlock? Like if we lock it while we're already locked, what does that mean? I mean, it's not showing up when I press, or like the hover effect isn't happening there anymore. We should also probably just add a log saying, hey, we're done. Done adding points. Yeah, but you see, like even here, it's so slow. We could honestly, I think it'd probably be okay to say if we add less than 10 points. Because like realistically, we don't need to keep going if we have only added, or we don't need to keep going if we're not adding any substantial amount of points. Although it is a little bit sad that this actually forces like, or like it pauses the frame rate. This would probably be not a bad idea to chuck into like a separate thread. I just don't want to deal with the multi-threading. I don't think it's worth it for this little thing. This little toy application is pretty much what it is. Wow. Okay, it goes on forever. Fuck it. Let's say if you're done, if you add less than 100 points, then we're done. And I just want to say int added is this added, and then I want to say just a log of added %d points. Just so we can see as it approaches, we're done. Like, just so we can actually get a number on the progress. Okay, we're done. This is fine. Okay, and then one more thing I want to add is the color space button. So is key pressed S or this? Show overlay and GUI button. I don't know why I'm typing that on, so copying it. This guy. Then here we can use text format, which creates a temporary buffer. I don't know what the lifetime on this is. I think it might just be for the frame. I'm not entirely sure, but I'm gonna work under that assumption. Let's say color Wait, is there like a multi-select? There's a combo box. Or a drop-down. Let's use a drop-down. Let's see, what does the drop-down control look like? Like functionally. It does not say. Great. If I look at the GUI button, and then I go to like the definition, or the declaration, wherever it is. This guy. What does the drop-down box? Drop-down box take? Takes the box. I'm confused. It takes the bounds, takes the text. How do you specify the options though? Unless it's specified somehow using like a fancy string in there. Like we saw in the message box that yeah, your answers are done in this kind of weird way. There's no documentation around here though. Unless it's like you use a different element. Okay, too much work. We're just gonna have a button that will say color, what's the word? Space. And it takes the color space, which is going to be this thing. Ooh. No. Oh no, it's up here. It's this thing. Actually, it's literally just this text format that I want. Except without the new line. And then this go there. And that comma goes away. And then now we've got an error. So yeah, this guy can go away. So now we've got color space is this, and it gets truncated. That's fine, we can make it bigger. Let's make it 300. Great, so now we've got point control, and we can change the like the space that we're using for color blending. And then ideally at some point in the future we add like OK Lab for color stuff. But before we do anything like that, let us, that's kind of fun. Oh shit, I did not mean to do that. That's fine. Before we do anything, let's take like a 5-minute break, and then we're gonna come back and do the start experimenting with the triangulation algorithm. So yeah, we'll be right back. And we're back. Okay. Now let's, I guess, get rid of all of this. I'll actually leave that open so I can reference it. Wow! New summarize pages in one click. Fuck off. Actually, there's also an AI thing in here, isn't there? Oh no. Anyways, okay. So Delaunay triangulation. Triangulation. Also, I think I'm saying it correctly with Delaunay, but who knows? Yeah, so it's like, hey, you take a bunch of points and you want to draw triangles, which is what we want to do for our nefarious purposes. It's really complicated from what I've seen, and I haven't actually looked into it too deeply because that's boring. But I found this page that kind of goes over, excuse me, a divide and conquer algorithm that we can use for the triangulation, and I want to try implementing it in C. So it's going to be kind of a pain based on having read through this a little bit. Originally spelled that and then changed to the French spelling. Okay, great. The Delaunay triangulation of a given set of points is defined by the following property. AB is an edge of the Delaunay triangulation if and only if there is a circle passing through A and B, so that all other points in the point set C, where C is not equal. Sorry. There is a circle passing through A and B, so that all other points in the point set C, where C is not equal to A or B, lie outside of the circle. Okay, so for every like pair of points in here, there's a line between them if you can draw a circle that does not contain any of the other points. Does that make sense to me? I think it does. I think that makes sense. Equivalently, all triangles in the Delaunay triangulation for a set of points will have empty circumscribed circles. Have to make sure to say that one correctly, otherwise Twitch will ban me. That is, no points lie in the interior of any of the triangle's circumference. No other points lie in the interior of the triangle circumference. Okie dokie. That one makes less sense to me, but I think I understand. There exists a Delaunay triangulation for any set of points in 2 dimensions. It is always unique as long as no 4 points in the point are set co-circular. Right. Because it minimizes small angles and circumscribed circles. Okay. The algorithms. Are there multiple listed here? I only saw this like top one. Is this all the same one? Hold on. And this is merging. Yeah, there's literally only one algorithm here. I don't know why it's spoilerized, but that's fine. I'm not entirely certain that we'll get this algorithm implemented, to be honest. Like, it's not trivial. And in fairness, I haven't actually done this kind of programming in a very long time. Nor geometry, for that matter. So we're gonna fucking figure it out. Great. So let's create a Delaunay .c, and we're gonna include standard int main void, int hello world. Return 0. No, standard IO. And then let's, in our make file, let's create a Delaunay .c. Great. Make Delaunay. And it says, hello world, professional C developer. Okay. In here, I want to include oh my god, include Ray. Shit. Ray, oh my god, I can't, why can I not type? Raylib.h. Like that. Init window 800, 600, Delaunay, triangulation. While the window should not close, we're going to begin drawing. We're going to clear the background with 1919 FF, and then we're going to end drawing. Great, we've got ourselves a little bit of a window here. Let's make it a little bit bigger. 1200 by 800, 900. Okay, that works. And then I just want to have, if I go back to our main, let me grab this guy. And then I want to grab the points. Or it's called vectors. This structure. And this is just going to be our list of points. And then I want to say vectors. Oh my fucking god. Vectors. Points is an empty vector. And then we're going to say if is mouse button pressed, mouse button left. Then we're going to say points, DA append, points get mouse position. Member reference type vector. Yeah, like that. Then we need assert. And we need standard length. Great. And then I want to say for. Let's do this before. For size t I equals 0, I is less than points dot count. We're gonna just draw a circle. Draw circle v at points items I with a radius of like 3. And the color is going to be white. Let's do gray white. So now we can click and place a couple of points. And this is what we're going to use for our triangulation. Great. Let's make the points just a little bit bigger. Yeah, so now we can actually see those, I think, all right. Yeah, okay, cool. So first step is to order the points. So the divide and conquer algorithm only computes Delaunay triangulation. For the convex hull of the point set, the first step is to put all the points into order of increasing x coordinates, and then increasing y coordinates. So we're going to use probably the worst function from the C standard library, which is qsort. Like actually, I think it's just the worst. And so we'll do this by saying, let's create a function, I think. I don't know. So a little bit of a weird aspect of this is like, how do I even word this? Like with this triangulation, we're coming up with the edges, but then with those edges, we need to come up with the triangles, right? So we need to get the list of triangles somehow, and I don't really know what that's going to look like yet. So, yeah, we're going to have to figure that out. For now, let's create a triangulate function, triangulate. Yeah, I guess that's fine. Which will do the sort itself. So we're going to have vectors, points. And I guess we don't need it by reference, or by pointer, I guess, because we're in C. And then here we're going to say triangulate the points. And for the time being, we'll just draw these edges until we can figure out how to collect them into some sort of structure. So first of all, we need to sort. So we can say Q sort, which is for a, what kind of sort is this? Oh, it's probably just a quick sort. That would be what the Q stands for. I don't know. It's a sorting algorithm. So N. So base is the pointer to the items. So this is points.items. Number of members is the number of members. So that's going to be points.count. Size is probably the size of the individual element. Yeah, it's N by size. So size is the size of points.items. And then the compare function is a function which can compare two points. Vec comp. And this is going to take int. Int vec comp. And it takes a void star A and a void star B. I think maybe a const void star. Does this say what the thing is? It does. It's two const void pointers. Can I change this pointer to be a const vector 2 pointer? No, it's an incompatible pointer. Great. So now we have to do this comparison. So basically, if let's do vector 2 VA is going to be vector 2 pointer on A dereference. And the same thing for VB. So if VA is less than VB, or okay, we can do this. So if VA.x equals VB.x, then we're going to say return VA.y minus VB.y. Otherwise, not even otherwise, we can just yeah, we're gonna do VA.x minus VB.x. And I think this might need to be B before A, but I never remember the order there. So this should be fine. So QSort just sorts in place. Let's do this loop down here. And say printf, open brackets. And then we can printf the close bracket. And then here I just want to printf the coordinates of this vector. So points at I dot, or points dot items at I dot x, points items I dot y. Format specifies int gets float. Yeah, that's true. And then afterwards, we're going to print it again. Technically, we should say if I is greater than 0, print f, comma. And we can even one line. Look at this. Look at this magical print line. So now, if we do this, we should sort the points properly. Okay, we get nothing. Oh, right, because we have nothing. Great. Let me just do this. So we just have 1 point and it stays the same. We get a second point. This one should stay where it is, and this should be added to the end. Okay, that's where it was, and we didn't have to resort. But now this one, this one will be added to the beginning over here, or no, this one will be added to the end on the first one, but it'll be moved to the beginning. Yeah, okay, cool. So we are now sorting our points. Fantastic. Okay, once the points are ordered, the ordered set is successively divided into halves until we are left with subsets containing no more than 3 points. These subsets may be instantly triangulated as a segment in the case of 2 points and a triangle. Oh, and a triangle in the case of 3 points. Okay. So this is going to be the weird part, I think. Yeah, so this is going to be recursive. This is going to be... so it's going to be recursive, but what is it going to turn into? I don't know that yet. So we're going to say void. Does this give a name? I guess divide. Takes... I don't want to give it like the actual vector, or not vector. Fuck, that's confusing. This is effectively a vector. The dynamic array, effectively a vector from Rust. It's a vector of vector 2's. I don't want to give it that. I want to give it effectively the equivalent of a slice in Rust. So this is going to be a vector 2 items, and then size t is going to be the count, or count is going to be size t, whatever. And then we're going to return void for now, but we'll figure that out in a bit. So if count is less than or equal to 3, then we're going to do something. Actually, then we're just going to print it. Oh, fuck, I deleted it. You come back. Then we're just going to print it. We can bring this back. I don't know why I collapsed it like I did, but whatever. This guy. Points here is now called items. Or I guess count. Items is just called items. Great. So now this will, if we have fewer than 3 elements, then we're going to just print them. Otherwise, we're going to say, what are we going to say? We're going to say left is count divided by 2. We're going to say divide items and left, and then we're going to say divide items plus left and count minus left. So this is effectively take the vectors that we have, split it in half, and then send each chunk to the divide. I think this is kind of what you do in like shell sort or something, where you split on like a middle point. In our case, the middle point is this guy. If I run this on this divide points dot items and points dot count, what do we end up with? So it's not going to do anything. If we have just a single point, it'll do this. It still didn't do anything. Oh yes, it did. That print is within this like divide. 2 points, it'll print both of them. 3 points, it will print all 3 of them. But then the 4th point should print what, these 2 points, and then the 2 points on the right. Right, so we get 3, 4, 9, 4, 6, 8. I guess that's this one. No, that's this one, and then this one. So 5, 5, 1, yeah. And then 6, 19 is this one, and then 7, 98 is that one. And if we do this again, then we should get one group of 2 and one group of 3. Yeah. Okay, so that's these 3, and then that's those 2. So that seems to be pretty good. I want to draw lines between them just because we can, really. Here's a question. Does, what is it called? Raylib have some sort of method for drawing triangles? It does. Takes 3 vectors. Draw triangle lines. Takes 3 vectors. Beautiful. Okay, so vector 1 is, or I guess we need to say if count is 3, then what? If count is 3, then we're going to draw triangle lines with items 0, items 1, and items 2. With, let's say ray white is fine. Ray white. Otherwise, if count is 2, then we're just going to draw a line between items at 0, items 1, and draw a line V with ray white as well. And then otherwise, this is technically unreachable, so let's just assert 0 and right, because the only case where we could get a count of 1 is if we divide a segment that is of length 2, or like we divide a slice of length 2, but that can't happen because we don't divide within this branch. Or of length 2 or of length 3. So yeah, that's fine. Unreachable. So now 1 dot, actually, I say that and then it immediately fails. We cannot triangulate on a single dot. So if points count is greater than 1. So 1 dot, 2 dots should draw a line. Except it didn't. 3 dots. Okay, none of this stuff is drawing anything. Why is it not? Let us see. Oh, because we're drawing it for a single frame. We did that because it's printing. It's fine. We'll just remove the printing. Oh, we still need the if statements here. So if points count is greater than 1, then we're going to triangulate. Bam, bam, we get a line. Bam, we get a triangle. Bam, we get 2 lines. Bam, we get a triangle. Bam, we get a triangle. Bam, we get stuff. Things are happening. It is interesting how adding a triangle over here affects like everything. Or adding a dot over here affects everything. Because we're now dividing into different chunks. But okay. Now what? Once the points are ordered, the ordered set can be divided. Okay, so we just did that. Great. The set has been halved into subsets of 2 or 3 points, and the subsets have been triangulated individually. Agreed. From here, the triangulated subsets are recursively merged with their former other halves. Okay. The final product of any merge will be a triangulation consisting of LL edges previously present in the left triangulation, having endpoints from their left subset. Okay. RR edges previously present in the right triangulation. I don't understand what this is. The first 2 merges are shown here. They were somewhat simple with no deletion of any LL or RR edges in either case. The next merge will prove to be a bit more complicated and demonstrative of the algorithm. Okay, let's finish reading this though, because I got distracted. Final product will final product of any merge will be triangulation consisting of LL edges, RR edges, and LR edges. To maintain Delaunay-hood over the merged point subsets, deletion of LL and RR edges may be necessary. However, we never create new LL or RR edges when merging. And just to refresh, LL is edges previously present in the left triangulation. RR is edges previously present in the right triangulation. So these are existing edges while merging. And then LR edges, new edges running between the left and right triangulations. Okay. And sometimes we might have to delete the LL and RR edges. That's fine. Ended up with a case like that. Like, yeah, this would probably end up you delete this guy. And you replace it with like this triangle. Maybe? I don't know, to be honest. I'm kind of just bullshitting. As one does. Okay. First two merges are shown here. They were somewhat simple with no deletion of any LL or RR edges, so any of the existing edges. The next merge will prove to be a bit more complicated and demonstrative of the algorithm. So it says that these are merged. Oh, I guess this is the same as this? Like this visual right here is this thing. So we draw a line from 1 to 4, but why? Or do we still discuss the merging further on? Yeah, I think so, okay. But either way, in here we draw a line from 1 to 4, and 4 to 3, and 5 to 2, and probably 5 to 3. Yeah. Okay. Interesting. And then we'll figure out why in just a moment. But yeah, so these can be merged pretty simply, but then merging these two structures requires deleting of some of the L or LR edges. So some of the edges on the individual sides. Here is our triangulation so far, with one more merge remaining. All left edges in the left triangulation are LL edges, and all edges in the right triangulation are RR edges. Agreed. Oh, but I guess this edge is going to be deleted. That's my working theory. The first step for merging two halves is to insert the base LR edge. Base LR edge is the bottommost LR edge, which does not intersect any LL or RR edges. Okay. Does that make sense? I mean, yeah, fundamentally that does make sense. I'm thinking more in the context of like implementation details. So the base is this edge, so it's the bottommost LR edge, which does not intersect any LL or RR edges. Okay. So, but it's not like a triangle or anything. So we'll probably end up representing this by just having a list of edges. Probably a list of edges and a list of vertices, or I guess points, because we're computer science context. Yeah, so just a list of edges, basically. And the edges will just be point to point. Yeah, I think that'll work. Working upward from here, we need to determine the next LR edge to be added just above the LR edge. Just above the base LR edge. Clearly, such an edge will have as one endpoint either the left or right endpoint of the LR edge. Yeah. The other endpoint then will come either left or right point in the subset. What will come either from the left or right point subset? Yeah. Naturally, we narrow our decision by selecting two candidate points. One from the left subset and one... Okay, fantastic. Let us begin with the right side. So on here, how do we select this point? Great. The first potential candidate is the point connected to the right point of the base, LR edge by the RR edge. What? The first potential sorry, this is confusing. To my weak little brain. Do we have? No, we don't have like a reader mode, unfortunately, for this page. I don't like how wide the text is. It's kind of making it super easy for me to lose my page place. Let's try this. First of all, let's zoom back in. Let's do a little bit of HTML on our C stream, or CSS, I guess, rather. No, fuck, not on the image. Fuck off. I want it on the content. This, no. The body. The DL. I don't know what DL is. Width is 80%. Margin auto. Really? Fuck you, Firefox. Margin auto. Bam. Beautiful. I am a web developer. Okay. That didn't help. Fuck. Let's do 60%. Yeah, that'll work. Okay. Great. Where were we? First step is adding a base LR edge. Great. Okay, working. Where were we? Let us begin with the right side. The first potential candidate is the point connected to the right point of the base LR edge by the RR edge, which defines the smallest clockwise angle from the base LR edge. Smallest clockwise angle from the base LR edge. That makes sense. Similarly, the next potential candidate defines the next smallest clockwise angle from the base LR edge. I don't understand this graphic though. So let us begin with the right side. The first potential candidate is the point connected to the right point of the base LR edge, right? So point connected to this point here. I hope my mouse cursor is showing up because I'm kind of just vaguely gesturing with it. Actually, you know what we can do? Hold on, I'm learning Sway, but I think I can do this. Fantastic. Now you can definitely see my cursor, I hope. Yeah, so down here we've got this point. And then the first potential candidate is the point connected to the right point of the base LR edge by the RR edge. So that's these edges. So we've got three edges, three candidates, which defines the smallest clockwise angle from the base LR edge, which will be this one. This long edge right here is the first potential candidate. Then we check for two criteria. The clockwise angle from the base LR edge is less than 180 degrees. Okay. Well, that's weird. What if it's not? Because if it's not, then we don't have anything else because it's the smallest. That's weird. We'll come back to it. The circumcircle defined by the two endpoints must not contain the next potential candidate in its interior. Okay. So this one contains this guy, so it's invalid. I don't know how to do that mathematically, but we'll figure that out. Or I guess geometrically, if we want to be precise. If both criteria are satisfied, the potential candidate becomes our final coordinate for the right side. So becomes our final coordinate for the right side. If the first criterion does not hold, then no candidate for the right side is chosen, and then we'd switch to the left side, I guess. If the first criterion holds but the second does not, then the RR edge. Oh, wait. If the first criterion holds but the second does not. Oh, okay. Yeah, this is the point that I mentioned just a minute ago, where if the first criterion does not hold, that means that the angle here between this LR edge is somehow greater than 180, though theoretically that shouldn't be possible. Oh no, it could be possible. If you end up with like a point down, or like a line down here, then we can ignore it, and then we just have to switch over to the left side because there is no other alternatives. Okay, that's fine. If the first criterion holds but the second does not, so that's the circumscribed, then the RR edge from the potential candidate to the right endpoint of the base, LR edge, is deleted. So if the first criterion, if the second doesn't hold, then the RR edge from the potential candidate to the right endpoint. So if the second criterion does not hold, then we delete this line. Okay. Great. The process is then repeated with the next potential candidate as the potential candidate. Wait. Process is repeated with the next potential candidate as the potential candidate until the final right candidate is chosen, or it is determined no candidate will be chosen. Right, so we just keep going. And so now we've got our potential candidate, and then this one is valid because it's less than 180 degrees, and this guy is outside of the circumcircle. Okay. Let's try to implement this. And I don't know how it's going to work, but we're going to find out. So first step, going all the way back, is we need to do this. So let's figure out a way to hold onto this data up here. So after we divide, we're going to return something. We're going to return basically a set of edges, I think. Yeah, I think that'll work. So let's create I guess edges, or an edge. So first of all, type def struct edge is gonna take 2 vectors, vector 2, A and B, which are the 2 points that are like that connect the edge, or not, that construct the edge. And then we're going to type def struct edges, which has items, count, and capacity. It's called edges. And this is a dynamic array. Actually, let's do that. Arguably, we could do like, we could be a little bit better about this. Could we? I mean, because technically, no. In this case, we have either 1 or 2 edges, or sorry, 1 or 3 edges. But not in all cases. So that's fine. We'll just do it this. This is fine. Yeah, okay. And then let's have divide return what? What is it going to return? I don't know. What should it return? Like I'm thinking an edges of edges. Like that's awful. Like a vector of edges. Like that's not even that's bad description. How do I words? A 2D array. basically. A list of lists. But I don't really want to do that. That doesn't sound terribly pleasant to work with. I mean, ultimately what we could do is like this merging thing only has to or merging can happen right here. Like I think that's fine. Yeah, I think we can have merging happen right here, which means that this is just gonna return an edges. Actually, because of reasons, let's do an edges this way. Actually, no, I take that back. We can just return an edges. That is actually fine. You go away, you go away. You're gonna be an edges. Yeah, that's gonna be fine. And then what this is gonna do here it feels really unnecessary to be allocating so much like this. I should probably get out of this headspace of allocations are bad. I mean, allocations are bad, but like, it's okay to do some allocations. It's 2025. We've got memory. We've got the compute to be able to do allocations. And this isn't something this is not a super, as far as I can tell, at this point, this is not a super compute heavy algorithm. I mean, it is compute heavy, but it's not greedy in terms of resources. I should stop talking. Let's just do this. Okay, so edges is 0 initialized thing. And then I want to say DA, although actually, you know what? The default is 1024. Let's default to 256. A lot of edges. Yes, this will end up being a lot of edges, but that's okay. That's ideal. We want to have a lot of edges. Okay, here we're gonna say DA append edges with an edge. Fuck, that's not looking like a word anymore. And it's gonna be items 0, items 1. Expression is not assignable. Pointer. Then it's gonna be items 1, items 2, and then it's gonna be items 2, items 0. Great, and that's all the edges. Fuck, too. One of the other things is edges. Fuck, edges are weird, because, like, they need to be ordered, or we need to check both sides. Although edges are vectors. Fuck. Yeah, ordering edges is kind of a pain. In this case, right here, we are ordered. And ordered doesn't really make sense. Although there is a defined ordering here, which is that we compare X and then we compare Y. That was defined up here. Yeah, this is fine. We'll just end up checking both when we're searching for an edge, but I think that's okay. Yeah, that's fine. Okay. Great. Yeah, that should be fine. Now let's add this other edge, which is this guy. And fuck, I didn't want to get rid of this draw triangle, but that's good. Let's put that back. So items 0, items 1, items 2. This is gonna be Ray White. This is going to be draw line V. Go to that guy. So now we're still drawing our lines. Boop, 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 boop. Great. This is still unreachable. But now, if we get to this point, then we have edges left and edges right. Redefinition of left. Yeah, that's fine. Middle is probably a little bit better here. So mid minus mid. Because this is technically like the midpoint. This is expecting to return edges. Let's just return 0 for now. Oh, and actually this is going to return edges. And then this is where we merge. So this is going to be merge, left, right. And I'm going to take left by reference, and we'll push into there, I think. Yeah. And then I also want to say this needs items, and this needs min. And the length of items. Right, because we need to actually have the list of points. Technically, we could reconstruct that using the left and right edges, but I think that adds overhead. That is unnecessary. Okay, so now we're going to have this merge function, which takes edges left, edges right, and size t, vector to points, and size t points count, size t mid. Great. Okay, so first step, according to this, is we need to find the base LR edge, which should be the lowest point of each side. Which does not intersect with any edges. So the lowest point is going to be 4. Yeah, sorry. 4 size t, I equals 0. I is less than mid. This is going to be f float infinity, I guess. What's from that? And then this is going to be if points I, y is less than min y, points I, y, or min y equals points I, y. Great, this guy, and then min I is obviously I. I guess min L, and then min R. And honestly, we don't even need this. We can say points at min L, y. And then we don't need to start at that. Bam, we just removed one whole iteration. We now have a smaller O of n. And then we do the same thing for this, except we're going to start at mid, and we're going to go to points count, and min r. And then we're going to draw line V between points at min L also min R should start off at mid, and this should be I plus, no, it should be I, yeah. Min L to points at min R, and the color should be ray white. Like that. And then this might work. Unclear. We should get a line between this point and the point that I'm about to place, I think. Or not. Oh, oak, because we're vertically inverted. I don't know if it matters. Actually, thinking about it. Does it matter that we have that we're inverted? I don't think so, but just for sake of making sure that everything is correct. Ah, fuck, this math is gonna throw me off so much. So the issue here is that 0, 0 is in the top left corner in Raylib and most graphics APIs. But the thing that we're looking at right now has the has 0, 0 in the bottom left, right? Like it says the lowest point. If we were to switch to using the maximum point, so the bottommost, would that break anything? Maybe. Let's switch to using max. We're gonna find out if it actually breaks anything, but I think it'll be a little bit nicer to like work together. Wow, look at this excellent triangulation. It's a little bit different now. Not a single triangle is formed here. Ooh, but this does highlight a point. We need to deal with triangle or with line intersections. So we only draw this point. Wait. Bottommost LR edge, which does not intersect with any LL or LR edges. Fuck, that actually makes it a little bit more complicated. Because how do we get that? So we can grab the bottommost points, but if those intersect, then what? The bottommost LR edge, which doesn't intersect with anything. So that would be how do we even obtain that? So we'd say honestly, I don't know. I'm kind of blanking here. This feels like a bad place to be blanking. Let's see. So basically, I want to... There are Rust things that I could do here. Like what I would do in Rust is make an iterator over the bottom most edges, I think. And I could bring that into here, but that feels weird. It would be cool if I had the points sorted by vertical. Like, sorry, that makes no sense. It would be cool if I had the points sorted by their Y component, which we could arrange. Would that be useful? That would be useful, because then you just grab 0, 0. Yeah, fuck it. Let's do that. So let's say we can't manipulate this. Oh shit, we actually could. You should stream Factorio. Have I done that? I think I've done that actually several years ago. I mean, I could. I don't really do game streams though, so. Can I manipulate those points? I think I can. I think at this point it's okay to manipulate it. We don't care about them being sorted anymore. So actually, yeah, let's do that. So this is going to be vec comp xy. And then we're going to do a different version, which is vec comp yx. No, actually, we're just going to do strict y comparison. And then down here, we're going to do another Q sort on points, with mid being the number of members, size of star points, and then the comparator is going to be vec comp y, and then we're going to sort again on points plus mid, size of points count minus mid, size of points, and using that comparator. Like that. Yeah, I think we're going to get to the point of drawing the baseline, and then I think we're going to have to call it for today, because it's getting pretty late, but we'll come back to this at some point soon. Okay, so we're now sorted by verticality. What is Q sort R? Does that just reverse it, or... Oh no, that takes an argument. Fuck you. Yeah, this is because C doesn't have closures. That's one of the many annoying things about fucking whatever this language, the libc, is that we don't have closures, so we have to have this nasty ass Q sort, which takes a function pointer that can have nothing cool in it. I actually fucking hate this language, but at the same time, I love writing in this language. Okay, so draw line is going to take points at 0 and points at max, which are now mid, sorry, which are now our beginning and end, or sorry, our lowest 2 points, I think. So if we do this, these should be the lowest. Boop, boop, boop. Boop. No, it's the smallest. So if we change this to B minus A, now it should be the lowest. Boop, 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 boop. Yeah, so now it's the bottommost point. Okie dokie. Now, where were we? In merge. So now we need to do intersections. So if intersects 1, if it intersects any, which, fuck. We can put an edge in here, I guess. Edge, which is points 0, points mid, with which does not intersect with any L or R edges. So edges, or I guess left or right. And we'll just have it take the 2 edges so that we don't have to combine them or anything yet. Right, so then we can void intersects any, takes an edge, and then edges left and edges right. And this can actually be dereferenced. And this is going to return a Boolean. Intersects any. Oh my god, I misspelled both of them. Intersects. Great. Does Raylib have a line collision? Like, it's got a bunch of collision stuff. Like, if I just jump here. Really? Really? etc, or I guess user lib raylib. What? Oh, user include, sorry. User include raylib.h. This guy. What kind of line functions do you have? Draw line, yeah, that's great. Splines drawing, spline segment. Check collision point line. Check collision lines. Yeah, check collision lines. It takes start point, end point, start point, end point, collision point. Oh, okay, it actually gives you the point of collision too. That's useful. Not in this case, but in other cases, I guess. Okay, check collision lines. Check collision lines. So for size t I equals 0 is less than left dot count. Then we can take the edge, so edge dot A, edge dot B. Starting position 2 is going to be vector 2, no, edge. C for, E for edge is going to be left dot items at I, E dot A, E dot B. If this, and it needs the pointer, but I think I can probably pass null. If we have a collision, we're going to return true. Otherwise, we're going to return false. And then we also need to do the same check, but for the right. Like so. Great. Okay, so then if we intersect any of these edges, then we need to increment the index that we're using for fuck. We need to increment the index that we're using. Let's try this. Bool inc left. This feels weird though. Like the weirdest part about this is it needs to be the bottommost one, right? Like, yeah, let's try that. So if inc left, size t left I is 0, right I is mid. I'm just gonna be left eye plus plus. No, plus equals 1. Otherwise, it's right eye plus equals 1. Right? No, fuck, that's not gonna work. Right, because if you have... actually, I've got a drawing tablet right next to me. Let's do that. It might not work because Wayland has not been having a great time with it. What's it called? Krita. New image. Okay, well that did not work. Content is... Great. Okay, you gonna work? You're not... Oh shit, you're actually working. What the fuck? Okay. Give me a better color. Oh, what the fuck are you doing? Why is this space all... Okay, we might not be doing this. This, like, fucking application just doesn't fucking work. And by the application, I mean the, That's fine, I'll draw by hand. Great. Give me a color, please. Thank you. Give me smaller. I say by hand. I mean with my mouse cursor. Yeah. So if we've got this point, this point, and so say for whatever reason we've got an intersection here. I don't know what the cause is, but say we've got a line here. Can I do that? Is scary. Can I do like a straight line, please? What the fuck? No, I can't. Okay, so we've got an intersection here. So we can't do this line. No, shit, sorry. Say we've got an intersection here. Fuck, no, I'm trying to think of a case. Yeah, I just had it in my head, but I've lost it. Yeah. Say we've got a line, a point here. Yeah. How do I erase? That works. Okay, so say we've got a point here, and 2 points here. If we want to draw a line here, but say we can't between these 2 points for whatever reason, and then we increment the left side. No, sorry, we increment the right side. This is no longer the bottommost line. No longer necessarily the bottommost line. It's like, say we have a line right here, for whatever reason. We could draw a line here, but if we increment the right side, then we end up here, which is not the bottommost possible line. This would be the bottommost possible line. So we need to increment to the next... Fuck, how does this even work? We need to increment the side that would have the smallest change in y coordinates. I think. Alright, so if left eye is less than mid, -1, and no, let's do this. Let's say vector 2 next left, no, sorry, left next is points at left eye plus 1. That's obviously broken. Or I guess it's not technically broken right now, but this will be in like a loop. Do I guess we can just do a while true loop here, like that. If we've got an intersection, then we're gonna do this, and I guess really this just becomes this. So if we have an intersection, then we're gonna do this. The next left is this guy. So really we need to check if I don't, so the weird part is here, like, what if we're out of left candidates, like out of possible points on the left? Like, what do we do? And the answer is I don't know. I guess then we are forced to increment the right. So if left eye is equal to mid minus 1 and right eye equals points count minus 1, then in this case we're out of possible points. So let's just say, like, effectively just panic, like out of candidates for base LR edge, right? That's what it called it, base LR edge. Great. Otherwise, if we have this case, then we know right eye plus equals 1. Otherwise, if we have this case, then we're going to say left eye plus equals 1. Otherwise, we're in this, like, final case. This we'll just put continues here. This doesn't need anything. Otherwise, we'll just continue like so. Effectively base cases. Fantastic. And then, so we'll say the next left is going to be this one. The next right is going to be this one, which we know both of these are safe to do now because we have enough points. Okay. Now what? So let's create a float dyl. So this is the difference in y's on the left. No, let's say left dy is going to be left next dot y minus points at left eye dot y. If left dy less than right dy, then we're going to say left plus equals 1, left eye plus equals 1, and then we're going to say the else is going to be right. And this isn't generally a case that matters, but out of candidates for base LR edge. Shit. Oh, it's possible that this is wrong. Let's do fabs. because it doesn't actually matter. Yeah, okay. My guess is we were doing comparison. Out of candidate, so it's still wrong. Which I guess makes sense that it would be wrong. But like, how do we make this better? So like how do we quantify the minimum height, like the lowest edge? That's the part I'm struggling with. Like I would be okay with saying for size t, I equals 0, I is less than mid plus I. At least just to figure out where the points are. J, J. And then here we say if intersects any. Actually, we're gonna just grab this again. And then this point is gonna be I, this point is gonna be J. Sorry, J is gonna start at mid and go to points len, points count. Right, so this is the current edge. Let's call it edge. So if we intersect with anything, then this is immediately invalid. Otherwise, and this is where the question comes in. Like, I guess really this. Can I rename? This is left eye. I can. This is right eye. Is what these are technically. And so like the minimum min L and is infinity. Min R is infinity. If points, or I guess edge dot A dot Y is less than min L, or edge dot B dot Y is less than min R, then min left I is left I. Sorry, RI is right eye. Size T, min LI is 0, min RI is mid. And like this is O of n squared, which is obviously not ideal. But like now it'll always come up with the lowest one, but now we're obviously looping over every single possible edge. which is just, I mean, obviously not ideal. I don't know. Seems fine, honestly. I don't know. Nothing is terribly broken. Okay. It's definitely slowing down though, which is unfortunate. Get ignore. Let's add Delaunay. Let me go to the README. Oh, I guess I should rename this, geometric wallpaper generator. Using Voronoi diagram or Delaunay triangulation. I don't like it breaking in the middle of links. I don't know why, but it's fine. Great. So we'll do this. And I want to say references. How do I add something to the web archive? I'm always scared that things will be yeeted. Do I just need to like look it up? Oh, it's been archived already. How beautiful. Gimme. Gimme? Duh. This thing. Yoink. Okay, very cool. This is whip. And actually, let's commit this to a branch. Yeah. Not what? Get branch B. Or what the fuck am I doing? Check out B, and we'll call this Delaunay. Initial start working on Delaunay implementation. Push that, and now it will be in this branch, and we can actually, let's open it as a PR in the state of draft. Nope. In the state of draft. Very nice. Look at the 6,000 line changes. We'll probably end up moving that raylib or raygui into a separate, into like a directory or something, but that's something we'll figure out later. Here is the link to the GitHub. And that will be all for today. So thank you for coming, and I will see you next time.